Dialogue with your microbes. Health and the fight against serious diseases are impossible without establishing a proper dialogue with the microbes in your gut. How can this be achieved? Think of the microbial community as a kind of farm, and the microorganisms within it as farm animals that you need to raise. An equally serious threat, as dangerous as terrorism and pandemics, is the spread of antibiotic-resistant bacteria. Every year, antibiotic-resistant bacteria kill 700,000 people. By 2050, if nothing is done, antibiotic-resistant bacteria will kill 10 million people annually. Recently, all 193 UN member countries committed to fighting antibiotic-resistant bacteria. According to the plan, in 2 years, member countries must present a plan to combat antibiotic-resistant bacteria. The document I'm talking about has not yet been signed, but it includes 3 main points. 1. Develop systems for monitoring and regulating the use and sale of antimicrobial antibacterial drugs for humans and animals. 2. Stimulate innovative ways to develop new antibiotics, as well as improve rapid diagnostics. 3. Educate healthcare professionals and the general public about preventing diseases caused by antibiotic-resistant infections. We are on the brink of losing one of medicine's greatest achievements, antibiotics. Antibiotics are widely used in all countries. Of the 3 points listed, the first 2 are very important, but the most crucial point is to train doctors to properly manage antibiotics and to teach the population about what is happening. And this is very challenging. In many countries, up to 70% of prescribed antibiotics are unnecessary. It is well known that viruses cannot be treated with antibiotics. Doctors tend to prescribe antibiotics too easily, which is a significant factor, but not all of it depends on the doctors. Antibiotics are also used in the agro-industrial sector, animal husbandry, poultry farming, and aquaculture. Antibiotics are added to food in these industries to prevent infections and to increase muscle mass. These are the same antibiotics used for human treatment. The E. coli in a chicken or pig is the same as in a human. Thus, microbes develop and acquire resistance to antibiotics, and we get resistant strains of microorganisms with food that is rich in antibiotics. Some bacterial strains have already become resistant to all antibiotics. For over a quarter of a century, no new types or classes of antibiotics have emerged. Developing new antibiotics requires more effort and time. Developing antibiotics is not profitable, partly because resistance develops, and their effectiveness declines. In the 1950s, the effectiveness of an antibiotic lasted 10 to 20 years. Now, a new antibiotic is effective for only 1 or 2 years. Additionally, the process of registering a new antibiotic and the necessary preliminary research takes 10 years, during which time microbes already form resistance. I also want to note that large-scale clinical trials are required, which take a long time and cost a fortune. The average time for developing a new drug today is 15 years, plus another 3 to 4 years for paperwork. On average, this costs €1 billion. A large portion of this sum consists of unnecessary bureaucratic expenses. Pharmaceutical companies that produce licensed drugs are interested in maintaining their income for as long as possible and preventing such new drugs from entering the market. For example, in Africa, tuberculosis has mutated so that no antibiotic can treat it from the outset. Stomach cancer, liver cancer, cervical cancer, and laryngeal cancer are infectious diseases. 17% of cancers are the result of infections. Cardiovascular diseases today are caused by chlamydial infections. There is a theory that obesity is also an infectious disease. And this will be like the COVID pandemic now. Of course, completely eliminating microbial resistance to antibiotics will not be possible. In the 1940s, a patient could be cured with a single penicillin injection. There was a case described in literature a few years ago when a patient was treated with all known antibiotics, and none helped, and the patient was not cured. The discovery of penicillin occurred in 1928, almost 100 years ago. Is it possible that an alternative to antibiotics will be found, something fundamentally new? It is possible, but antibiotics will still remain. Perhaps only new rules or methods of application will be developed for them. New antibiotics will come, but microbes will eventually develop resistance to them too. Let's talk about microbes themselves. And how bacteria control us. We think that our behavior is controlled by our brain, but we never consider what or who controls our brain. The brain controls not only our behavior but also all the organs in the body. The control of the organs is carried out through nerves that connect the brain to various organs and tissues in the human body. My father, Dr. Burrell, in 1965, proposed a unique treatment method based on research he had reviewed. When my father got acquainted with studies published in medical journals, these studies claimed that cerebrospinal fluid taken from an animal with a brain stroke was then introduced into a completely healthy animal. After the introduction of this cerebrospinal fluid, the healthy animal developed symptoms of a stroke. This study demonstrated that there is a real possibility of influencing brain activity through cerebrospinal fluid, even without the need for anatomical or pathological changes in the healthy organism. Dr. Burrell had questions, which he answered with the method he proposed, life sound therapy. You can read more about it in the book I wrote, Life Sound Therapy. In 1970, when I was studying at the medical university, the professor and head of the Department of Normal Anatomy published the results of his dissertation on nerve innervation. In this dissertation, he proved that even the most distant nerve endings of one nerve are innervated by the endings of other nerves. The human body is covered by a network of nerve endings that control and regulate each other. Around each nerve, cerebrospinal fluid circulates. There is a principle of feedback in the human body, which means that when the brain gives a command, it also receives feedback on how the command was executed. Signals through the nerves are transmitted not only from top to bottom but also from bottom to top, to the brain. It seems unimaginable that the brain and the stomach are so connected. However, the first thing necessary for the survival of the body is food, and this means the brain must clearly understand whether food is available, what is happening with it, and whether the digestive system is functioning well. Humans and microbes have united for the most valuable thing needed by any living organism, food. Humans know how to acquire it, and microbes know how to digest it. However, for peaceful coexistence, they need to follow a non-aggression agreement. Therefore, the accumulation of immune cells in the wall of the intestine sends information to the brain about the presence of necessary bacteria. In response to this information, the human body softens and controls the immune response to the presence of these microbes. If this does not happen, for example, due to a lack of bacteria, the human immune system is not controlled and becomes more aggressive. This may be why children raised in conditions of reduced bacteria, in cleanliness, without contact with their mother and her milk during artificial feeding, are more likely to develop allergies and autoimmune diseases. For their part, microbes do not destroy the intestinal walls. However, they remain peaceful neighbors only as long as the wall remains normal and healthy. If it is damaged, microbes will penetrate it and enter the human body. There, they cause severe inflammation that is difficult to fight. Moreover, microbes require protection for their interests. For example, they need food to come to them regularly and for the intestinal wall not to harm them. To ensure this, they release signaling molecules that regulate the activity of the surrounding host cells, such as regulating absorption or enzyme secretion, or even fat deposition. Sometimes, this coexistence leads to strange effects. For example, microbes can absorb medications taken by the host or modify them in some way, significantly reducing the effectiveness of the treatment. It seems that there is a bit more commonality between us and our microbial inhabitants than it first appears. On the one hand, danger is always near. On the other hand, it's impossible to get rid of it, as the absence of microbes results in even worse consequences than their presence. For example, according to the hygiene hypothesis, an excessive obsession with cleanliness and hygiene is harmful to health, while early exposure to bacteria and allergens strengthens the immune system. However, articles are still being published by authors who regard microbes as parasites that use humans for their own purposes. In this case, the influence of microbiota on the human nervous system becomes a strong argument. The intestinal wall is populated by immune cells that closely monitor the substances entering the body. When a threat is detected, these cells trigger inflammation, releasing substances that act on nerve endings and enter the bloodstream or, according to Dr. Berla's hypothesis, the cerebrospinal fluid. This way, localized stress can become global. Information about bacterial activity also quickly reaches the brain. First, peaceful microbes stimulate digestion, and many of the products they digest or synthesize enter the bloodstream. For example, short-chain fatty acids, which, when broken down, provide 5 to 10% of our daily energy. Brain cells have receptors that capture these fatty acids and signal satiety. Additionally, when there are sufficient energy resources, the brain develops better. Children who experienced food shortages while in the womb are more likely to suffer from schizophrenia and bipolar disorder. On the other hand, increasing the amount of short-chain fatty acids in the blood stimulates learning and memory. Second, bacteria actively communicate with the intestinal wall, and through it, with the brain of the host, releasing substances that act on enterochromaffin cells. Interestingly, the signaling molecules produced by bacteria are almost identical to our own hormones and neurotransmitters. It turns out that the gut microbiota can produce norepinephrine, dopamine, serotonin, testosterone, histamine, as well as the neurotransmitter gamma-aminobutyric acid and appetite-regulating proteins, such as ghrelin and leptin. Moreover, some bacteria can secrete benzodiazepines, substances with a calming effect, such as the well-known tranquilizer phenazepam. Scientists believe these signaling molecules are very ancient and were used by bacteria to communicate with each other during the early stages of multicellular organism development. Researchers have discovered a link between the state of the gut and anxiety, autism, neurodegenerative diseases such as Parkinson's and Alzheimer's diseases. Perhaps the cause of depression lies not in the brain, but in the gut. Serotonin, the happiness hormone, is synthesized from tryptophan, an essential amino acid that we obtain from food and which is converted into the hormone by enzymes in the body. The gut itself sends signals to the brain via nerves. These signals are received from the microorganisms inhabiting the gut. Microbes do this in various ways. The influence of the microbiota on behavior and mood has been proven through numerous experiments. We all know how the food we eat affects our mood. At a basic level, the motivation of microbes is simple: they want food. If there is insufficient nutrition for them, they may release substances that stimulate nerve endings in the intestinal wall. If the host is mature enough, the microbes regulate food intake directly through the nervous system. For instance, when there is enough food, some of our beneficial microbes synthesize the essential amino acid tryptophan, which our body uses to produce serotonin, the so-called happiness hormone. Serotonin, in turn, regulates the activity of the nervous system, inducing feelings of satiety, calmness, and joy. In times of food scarcity, microbial hormones and neurotransmitters can shift behavior towards anxiety and exploratory behavior. Many disorders can be caused by an imbalance of neurotransmitters influenced by gut bacteria. Moreover, microbes want not just any food, but their favorite food. The microbiota consists of many types of bacteria with different dietary preferences. Each species of bacteria seeks to influence the host's body in such a way that the host consumes more of the substances they favor. This is likely why people who follow different diets have different gut microbiota compositions. Various microbes cause cravings for different types of food. They achieve this, for example, by redistributing taste receptors. It is known that taste perception can change after intestinal surgery, which inevitably alters the microbial composition. But even among people who eat the same diet, bacteria can shift food preferences. Scientists compared the bacterial substances in the urine of sweet-toothed individuals and those indifferent to sweets, even though both groups had the same diet. It turned out that these substances in the urine were different. This suggests that the craving for sugar may be a trait of the microbiota, not the host. So, if you think you have a pathological love for chocolate, it's possible that your microbes actually love it. By influencing the food preferences of the host, microbes compel them to eat foods that promote their growth and reproduction. Perhaps when you can't resist that cake, it's not due to weak willpower, but because of microorganisms. However, the more diverse the gut microbiota, the less likely it is that one species of bacteria will dominate over the others and take control of our brain. Microorganisms have their own evolutionary reasons for controlling our behavior. According to scientists, bacteria stimulate their hosts to socialize because it promotes the exchange of microbiota. Microbes want to travel, enter other organisms, and exchange genes with distant relatives living in other hosts. Therefore, it benefits them to enhance human sociability. Can microbes influence our emotions and actions? Scientists have discovered that lonely individuals who avoid social interaction have a significantly reduced number of Lactobacillus reuteri bacteria in their intestines. This microorganism affects the production of oxytocin, the hormone that regulates social behavior. Researchers found that a high-fat diet suppresses Lactobacillus reuteri in the mother's intestines, and she passes on her disrupted microbiota to her offspring. L. reuteri is a beneficial bacteria that inhabits the entire length of the digestive tract of a healthy person, starting from the mouth. According to numerous studies, the presence of L. reuteri positively influences the balance between good and bad microorganisms in the gastrointestinal tract. By supporting the vitality of beneficial microorganisms and maintaining a healthy microbiota balance, L. reuteri indirectly strengthens and supports the body's immune system, primarily by protecting the gastrointestinal tract from pathogenic microorganisms. Additionally, L. reuteri themselves have a direct positive effect on immune defense mechanisms, 2 to 4. The most interesting thing is that when interacting with others, people exchange microbiota. As soon as the microbiota normalizes, a person no longer strives for loneliness and self-isolation, and their social behavior returns to normal. Experiments studying the influence of gut microbiota on people's psyche show that depression and anxiety disorders can be treated with probiotics, beneficial bacteria. Scientists have coined a new term for them, psychobiotics. Our mood largely depends on what we eat. Can microbes influence our emotions and actions? It turns out they can not only do that but also much more. Trillions of microorganisms living in the gut are in constant communication with each other and with the brain, and this connection largely determines both our overall condition and even our life decisions. Moreover, disruptions in this interaction can lead to the development of depression, autism, dementia, and Parkinson's disease. Health and the fight against serious illnesses are impossible without establishing the right dialogue with the microbes in our gut. How can we achieve this? Proper cultivation of the gut microbiome. Think of the microbiome as a kind of farm, and the microorganisms that make it up as livestock that you need to breed. What will you feed them to ensure diversity, stability, and the health of the herd, and to optimize the production of beneficial signaling molecules that influence the brain? Should you include in the microorganism's diet foods that, contain potentially harmful chemicals or additives? By the way, the answer to this question is the first step towards starting to control everything you eat yourself. A person who is aware of the consequences of consuming fast food has a lot to consider when they go grocery shopping or choose a dessert at a restaurant. Recent studies have shown that consuming processed meat, especially those with high fat content, increases the risk of several types of malignant tumors, including breast, colon, and prostate cancer. Excessive consumption of animal fats is also harmful to the brain. A highly diverse microbiome composition will increase your body's resilience to chronic diseases. If you want to achieve this, include foods in your diet that nature wouldn't have spent millions of years evolving if they didn't benefit your health. Learn to listen to and understand your stomach and intestines. According to the U.S. National Institutes of Health, NIH, only 10% of the cells in the human body are human cells. The other 90% belong to microorganisms that inhabit various biotopes of the human body. Their number exceeds 100 trillion. Back in 1681, Leeuwenhoek identified microorganisms in human feces and hypothesized about the coexistence of different bacterial species in the gastrointestinal tract, GIT. In 1888, I. Mechnikov suggested that the cause of many diseases was the combined action of toxins and other metabolites produced by bacteria, which abound in the GIT. In his work, The Etudes of Optimism, he wrote that the numerous associations of microbes inhabiting the human intestine largely determine its spiritual and physical health. Mechnikov II, 1964. The term dysbiosis was first introduced by German physician Alfred Nissl in 1916, referring to disturbances in the gut flora related to changes in the number of Escherichia coli. Nissl A, 1916. More than 60% of the entire human microbiota colonizes various parts of the GIT. The total mass of bacteria associated with the GIT in a healthy person reaches 2.5 to 3 kilograms. There are no humans devoid of microbes.